Welcome to Unit 2.6, Guided Notes. We're looking at literal equations. Literal equations are looking at the concept of solving for a variable when there's multiple variables in the equation. So like if it's 2x plus 3y equals 12, sometimes it'll tell you to solve for x, sometimes it'll tell you to solve for y. Or some of our formulas and things like engineering and science and chemistry, some of our formulas are all variables. So what if it's given to you in area is length times width, and you know the length and the area, and you need to rearrange the variables to find the missing one, right? So that's what we're going to figure out. Literal equations are equations with multiple variables. Equations with multiple variables. All right, so for example, if you have 2x plus 3y equals 12, or if you have area equals length times width, multiple variables, right? It's going to tell you which one it wants you to solve for. So these ones say solve each of the equations below for x. Simple enough, right? Add 5 to both sides using inverse. 2x equals 18. Divide both sides by 2 using inverse. X equals 6. Simple enough, right? We know how to do that. That's a basic, two-step equation. We can do that, right? What if they're all variables? We still want to isolate the x, right? So there's a negative b, so we're going to add b to both sides, right? We're still using inverse property. The difference is we don't know what b is. So we're going to use the inverse of negative b to move it to the other side of the equal sign. So now we're left with a times x is equal to b plus c. We don't know what b and c are, but they're not like terms, so we can't combine them. Like over here, we could combine them because we knew what they were, and they were both constants, so they're like terms. And then we have a times x. Over here, we divided by our 2. So over here, we're going to divide by our a, right? We're left with x, which it told us to solve for, is equal to b plus c divided by a. All we're doing is manipulating the variables. We're moving it around based on what information we're given. In this case, we're solving for x. A different one might ask us to solve for a, or b, or c, and we have to manipulate the variables to isolate our chosen variable. Alright, so it says identify the similarities and differences between the two equations. Alright, both use inverse or opposites, right, to isolate the variable, to isolate x. Right? That's how they're similar. They both use inverse operation, inverse properties, or what's basically opposites, to isolate the x. Now, how are they different? The literal equation does not simplify simplify nicely due to multiple variables, right? Due to multiple variables, right? That's the difference. When you know the values, you can get it down to one simple answer. If it's multiple variables, it's never going to be that simple, right? That's the difference. The process is exactly the same, but the difference comes in how your answer looks. Right, so let's practice this a little bit. 1 steps, right? So it tells you, solve for W. This is L times W, so we're going to divide both sides by L. So W is equal to A divided by L. All we did is manipulate it to isolate the W. This one says solve for H. B times H. So let's divide both sides by B. That means H is equal to A divided by B. All we're doing is rearranging. Solve for T. Divide both sides by R. T is equal to D over R. And you notice how I'm flipping the answer? Because symmetric property says that if the left and the right are equal, I can flip the problem. Right. Solve for T. To isolate the T, we got to get rid of the P times the R. So let's divide by P times R. So T is equal to I over PR. Does anyone know what those variables stand for? Interest, rate, principal, and time. This is all about investments. Alright, and then this one says solve for H. So let's divide by LW. We're left with H equals volume, height equals volume, divided by length times width. These are formulas we know, either from geometry or from science, engineering. Solve for R. Area equals pi r squared. Now we're dealing with circles. But we're solving for R. Okay, this one's going to be interesting because we got to get rid of pi. So divide by pi. So we have r squared, because this is r squared, is equal to area over pi. The opposite of something being squared is the square root. So we have to find the square root, right? And because we're finding the square root, that cancels the square. The opposite of squaring something is to find the square root. Alright, so what we're left with is r is equal to the square root of a over pi. I know that one was a little more complicated because we're not used to square roots, but we really need to be used to square roots because of the opposite of squaring something. Square root. Root of the square. Get it? Alright, and then solve for C. It's C minus S. So let's add S to both sides. We're left to C equals M plus S. Solve for M. We got to get rid of this divided by V. We're going to multiply both sides by V. We're left with M equals dV. Miles, distance, and velocity? I don't know.